In this video, I am going to explain Brock's equation. Brock's equation. Consider the incoming X-rays with wavelength lambda strikes a crystal at an angle theta and bounces off at the same angle theta as shown in the figure. So here the first ray is incident at point A and diffracted with an angle theta, and second ray incident at B on the second plane of the crystal, then it is also bounced back like BCF. So if you observe, both first ray and second rays have the path difference. Second ray traveled more distance than first ray. The path difference between first ray and second ray is equal to dB plus BC. We need to find the path difference between these two rays. The distance that X-rays have traveled to reflect from second layer is more than that of first layer. The extra distance travels is equal to dB plus BC. The reflected X-rays will be in phase, that means constructive interference, if the extra distance is equal to an integral multiple of wavelength. So the extra distance dB plus BC, it is not AB, it is dB plus BC. And from the figure ABD, we have a diagram. This is a right angle triangle. So in this right angle triangle, it is a right angle triangle. This is A and this one is B and this one is D. Here right angle is in this point. Right angle is at this point. At this point is right angle. So here is theta. Here theta value. Okay. So here if you take sine theta, okay, sine theta, what is the formula for sine theta? Opposite side by hypotenuse. Okay, so that is equal to, what is opposite side here? Theta opposite side dB. Okay, dB divided by hypotenuse. Hypotenuse is opposite to 90 degrees, that is AB. So sin theta is equal to dB by AB. dB by AB value is equal to the distance between two parallel crystal planes. So therefore it is denoted by small d. It is taken as small d. So therefore from this equation you can find dB is equal to d sin theta. So we want to find dB plus BC. Similarly, there is another triangle. This is the straight AB. This is the distance between two parallel planes of crystal. Then here we have to draw a perpendicular line to that plane. This is the plane, and this is the plane. You have to draw perpendicular line. So therefore that perpendicular line is at See, so this is 90 degrees, here is 90 degrees, and theta value is it is theta. Okay, so we applying the same formula here also for this right angle triangle. Sin theta is equal to opposite side by hypotenuse, opposite side is BC and hypotenuse is 90 degrees opposite side AB. Okay, so therefore sin theta is equal to BC, right as it is, and AB is D. So therefore BC is equal to D sin theta. So here also we have that formula, BC is equal to D sin theta. So here you can observe that two important equations. One is dB plus BC. dB plus BC value d sin theta plus d sin theta, that is equal to 2d sin theta. Okay, from 1 and 2 we get 2d sin theta is equal to n lambda. This is, so therefore the path difference 2d sin theta is integral multiple of wavelength of X-rays. So therefore d is equal to, in this formula, 2d sin theta is equal to n lambda, d is equal to interplanar distance, and theta is equal to angle of incidence of X-rays, and n is equal to 1 to 3 integer. So this is Brock's equation, BRA, Brock's equation. And one more important thing is you can write the Brock equation in 2d is equal to n lambda divided by sin theta also. And you can write Brock's equation like this: sin theta is equal to n lambda by 2d. Here more importantly, n lambda, 2d sin theta is equal to n lambda is Brock's equation, and theta is equal to angle of incident X-rays, angle of incidence. Okay, thank you so much for watching.